Hi everyone, welcome back. In this video we're going to start to look at trigonometric functions or ratios. For example, sine, cosine, tangent. We're going to start to look at them as functions where angles are our input and then the output is some part of the unit circle that corresponds to that angle. Okay, so to start off, we have already looked previously at how we can relate angles in the unit circle to points on the unit circle. So if we have some angle theta here, and then we're looking at some point xy on our unit circle, in other words, the point that the terminal side passes through on the unit circle, we know that sine of theta is equal to the y value of that coordinate point. Similarly, we know that cosine of theta is equal to the x value, and tangent of theta is equal to sine over cosine. Which is y over x, the y value, divided by the x value. So we can relate the coordinates that we see on the unit circle with the sine, cosine, and tangent of the angle. In other words, it's some kind of relationship between the angle and then these coordinate points on our unit circle. Next up, I want to introduce a few more trigonometric terms. So sine, cosine, and tangent we're really familiar with. There are a couple of other names for trigonometry that we're going to be introducing and using in the future. Those are cosecant, secant, and cotangent. And all of these can be defined in terms of sine, cosine, and tangent, which we're already familiar with. We've talked about a lot already. Cosecant is sometimes shortened to, CSC. We can't do cos because that's cosine shortened. Cosecant of theta. And cosecant of theta is just the reciprocal of sine of theta. So 1 over sine of theta. Secant is sometimes shortened to SEC of theta. And again, we're looking at the reciprocal, this time reciprocal of cosine of theta. Cotangent is COT of theta. And again, we're looking at the reciprocal of tangent, 1 over tangent of theta, which if we look at our ratio up here, we can write this as cosine of theta over sine of theta, the reciprocal of that ratio. So when we see cosecant, secant, and tangent, we're just looking at reciprocals of those three functions, those three trig functions that we're already familiar with. How I remember it is cosecant isn't cosine, it's sine. So those are connected, but they're not the same. Secant is cosine because it doesn't have the cos in front of it. And then cotangent, well, it has tangent in the name, so inverse of tangent. Okay. Similarly, we can write these as 1 over the y value that we see on our unit circle, 1 over the x value, and then down here we have, instead of y over x, we have x over y. So we can also relate these to the coordinate point, the x and the y values of the coordinate point that we see on the unit circle. Okay, so sometimes you'll see these functions and we'll be working with them quite a bit in the future, so just knowing they relate to the functions that we're familiar with. Okay, so what we're going to talk about today is that we're going to look at trigonometry and think about how trigonometry, specifically sine, cosine, and tangent, can be thought about as functions. So in geometry, we worked a lot with sine, cosine, and tangent. If you remember, we have SOHCAHTOA by looking at right triangles. Then we have some angle theta, and then we can write, if this is maybe A, this is B, we can write sine of theta, for example, as B over C. So here, these are called trig ratios because we defined the trig function or the trig value, sine, in terms of a fraction or a ratio of side lengths of a right triangle. We can extend this idea and think of sine not only as a ratio of a right triangle, but looking back at our unit circle, we can think of sine as a relationship. So a relationship between some angle, theta, and the point on the unit circle corresponding to theta. In other words, when I talk about the point, I'm saying the point that the terminal side intersects the unit circle at. So up here, the input is going to be theta. That's our input for our function. And then the output is going to be something related to the point that we get on our unit circle that terminal side intersects the unit circle through. So here, this is our output, if we think of this as a function. And thinking of sine, cosine, and tangent as a function allows us to kind of like move away from right triangles and always having to draw right triangles, and think of them separately as their own relationship or function that we can study, and we can apply what we already know about functions to sine, cosine, and tangent. So for example, if we think of sine of theta, that's just equal to the y value that we see on the unit circle. So wherever we are on the unit circle, we're relating the angle theta, that's our input, to whatever the y value is for that point on our circle. Let me pull up another unit circle really quickly. Okay, so sine of theta is equal to y, so we have some angle theta, as I drew before. Theta is our angle from our standard position. The positive x-axis is where we're starting. And then this point on the unit circle here, and we're looking at the y value of this point. And so whatever angle we input, we can look at the unit circle, identify what point we're intersecting the unit circle at for that terminal side, and then find the y value, and that's our output for sine as a function. And there's a few things to notice. So first, because we're going around a circle, the y values are going to repeat. In other words, if we add one full rotation, we get the exact same point on the unit circle, xy. So in this case, if we were to add one full rotation, here we have theta plus one rotation is 2 pi radians. Then the corresponding point for this angle, theta plus 2 pi, is also xy. That same, in other words, with sine, that same y value. So the y values, or the outputs, repeat every time we add 2 pi to our input theta. And this is called a periodic function. Periodic functions have outputs that repeat for multiples of some value. So in this case, sine of theta plus 2 pi times, if k is just any integer, k is within integers, we could go 2 pi, we could go 2 pi's around the circle, we could go 3 pi's around the circle. No matter how many times we add 2 pi, we'll end up in that same exact spot. Sine of theta plus 2 pi times k is equal to the y value of that original theta. So here we have the value that we're adding a multiple of, and then the output remains the same no matter how many times we add it. And this also happens with cosine. So cosine of theta plus 2 pi times k is equal to cosine of theta. Okay, so sine and cosine are functions. They can be called periodic functions because they repeat. And then you might notice that the domain for sine and cosine can be found by looking at the y and the x values on our unit circle. So if we look at the y values, the maximum y value that we ever achieve for any point in the unit circle is 1. And the minimum y value is -1. So for our range, sine of theta is always going to be less than or equal to 1, greater than or equal to -1. For our domain is actually just going to be any x value or theta value For now, we're just talking about the real number set. So any x or theta value works for an input, because we'll always be able to rotate around the circle a certain number of times to find our angle. Cosine is exactly the same if we look at our x values. 1 is our highest x value, our largest x value, and then -1 is our smallest. So cosine of theta is less than or equal to 1 and greater than or equal to -1. And our domain is exactly the same, where any real number can be put in as an angle that we go around the circle. So that's actually going to be all that we cover for this video. So again, just looking at sine, cosine, and tangent, and relating them, thinking of them as functions relating an angle to the point that we end up with on the unit circle.